Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem flattening a linked list. So the problem states that we are just given head of a linked list to just flatten the linked list. So what does this flattening a linked list mean? That we are given a linked list like this and we just have, and in the problem statement says that next points to the next node in the list, that next points if we are standing here to this linked list, so the next points to the next node, that is this 10, and bottom points to the below node, so that is this 7. So now we can, so we have understood what this next and bottom pointer says, and we just have to flatten this flattening means that we have to convert this kind of linked list using containing next and bottom pointers. We just have to flatten this. We just have to convert this into a singly linked list. So this singly linked list means that we should have the linked list like this. Means we have to written the head of the linked list this, and the linked list is just a, we can say that linear or singly linked list is this there, and if we have to move ahead we can just uh, what we say that if we have to access the next node we have to go bottom. So flattening means to convert this kind of linked list to this vertical linked list such that it has only bottom pointers. All right, so we have to just return this head. So now how we can do this? So the brute force approach is to store all the nodes into an array and just sort the array and then again convert that array into the linked list. So for accessing all the elements, let's say here across this size is n and at max it is m. So accessing all the nodes, this will take n cross m time complexity, and then storing it into an array, another space n cross m space also. And now what we say, we have to uh, sort the linked list, sort the array. So this will take log of n cross m, log of n cross m time complexity, and then we have to again convert this into linked list, so again n cross m time complexity. So this will be the whole time complexity, and space complexity will be big of n cross m, but this will be brute force approach. And we have to now just we can see expected time complexity is big of n cross m. So we will just what we say optimize it. So I will tell you optimized way. So suppose we have this linked list. All right, so the most optimized way to flatten this linked list, what we can do, uh, suppose we are at the last linked list. Let's say this as L2 and this node as L1. So we all know these both are uh, two salted. In the question it is given these bottom vertical linked lists are salted. So we all know these linked list, these two linked list, that these vertical linked list are salted. What we can do, we can call merge function. We all know how to merge two salted linked list. If you don't know, you can watch my how to merge two salted linked list, or watch any uh, method on YouTube or Google. So we go and ask to merge these two linked list, these two sorted linked list, and what we have to keep while merging, that we have to deal with bottom pointers, not the next pointers. So yes, we will use the same code for the merging two sorted linked list, but we will just keep in mind that we don't have to use next pointer, we have to deal with bottom pointers. Now we will just say that go and merge these. So after merging, this, so after merging what will it look like? After merging this two, it will merge this and this will be flattened now. This will be flattened. So if I tell you this will be deleted, if I copy this anyhow, if I am able to copy this, so now if I tell you here, so this will look like something this, and here we can see that this will be now deleted and this will be now sorted. So after sorting this will, after after merging these two, this will return as a new flattened linked list. So flattened linked list will look like 9, 10, 11, 30, 35 and 40. My writing is not very good, so anyhow I am able to move this. So this will look like this. Alright, so this is sorted. Now again we will call, uh, what will be, this will look like this after merging these two linked list. After merging these two, this will look like this flattened way. So in real, how we will do this? We will just put recursion. Suppose our head is at this pointer and we are standing here. So let's say our temporary is here. All right, now we will keep calling our we will keep going up to the end. We will go here, then here, then here, and whenever we will see that we have reached the end node, we will just say, just return these, the L2, return this. When we will reach the end node, so I will say that just return this, return the head of the last node. Now well, when I will be here, all right, after recursion backtracking will be there. When I will return, I will say that now my head will be this L1, and now my, after returning, that is backtracking, I will have the merged head. I will say new head or merged head. This will be my L2. Now I will call merge function. Alright, now again after merging this, so backtracking will be there. So this will be my new L2, and I will be here. This will be my new head. So now I will again call this merge function. Again these two will be merged. All right, so again after merging this, they both will be merged. So after merging them, they will look like this. So again my backtracking will happen and I will go back, and I will have my current head as this and my new head. After backtracking, it will come. So this will be there. Now again I will call to merge them. So now when I will merge, these 5 and 6 will be placed at their correct position. 5 will be here and 6 will be here. Now this will be pointing to 9. So this way my whole linked list will be flattened. So the main logic is to just go at the last and just merge these two last two nodes. All right, these 9 and 30 nodes, merge them using merge function, and whenever they will merge, they will create a singly linked list. uh, but we have to keep in mind that while using that merge function, you have to deal with bottom pointers, so they will merge in bottom way, then vertical way. Now again we will backtrack, we will have a new current linked list and a new merged linked list. Now again we will merge them, we will go backtrack and we will do the same, continue, we will continue this. So if I go and implement this, what I said, first of all, first of all what I was saying, that wait, I will say that my new head, I have to go till the end node. I have to go to the end node. So I will call flatten. Alright. And I will call next of the root. And once I will reach the end node, after next, 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 but when I will reach here, then I will return this. Then I will return the current node. Alright. So I will write the base case also. So base case will be if root is null, if there is no root, or if I have reached the end node, I will say that return return root, because if root is null, then also I will say that uh, flattening list will be null, I will return null. And if I have reached the end node, I will return the whole end list. Alright. And now after returning, let's say I'm at the last. Alright, let's say I'm at the last and I have written the root. Alright, let's say I am at the last here and I have written this linked list. Now after backtracking I will be here. After backtracking I will be here. Now my current, this will be root. This will be my current position where I am. Where after backtracking I will just call my merge function, and in the merge function I will say that go and merge the root, that is my current node, current linked list, first node, and the node which I have got uh, after the merging. So in this case I will return this L2, and when I will backtrack to this node, my root will be this and my new head will be this L2. So I will just merge them, new head. So, and after merging them I will return. Now if I write the merge function, we all know how to write the merge function, we all know. So in the merge function, what I was sending, root and new head. So how merge function was working, I was having two lists. All right. And I'm recalling how we used to merge. So we used to have a dummy pointer. This will be having new node, let's say -1, and now I will be having a temporary. We all know how to merge two sorted linked list. If you don't know, you can watch my lecture or any other on YouTube or Google. So this will be currently my dummy, and while temporary is alive, so I will say that I'll say, let's say I have to merge the two linked list. So first pointer is here, second pointer is here. So I'm taking this as pointer 1 and pointer 2 for easiness. Pointer 1 and pointer 2. Now while pointer 1 and pointer 2 are alive, pointer 1 and pointer 2 both are alive, I will check the values. If value of pointer 1, that is in this case this is data, if pointer 1's data is less than pointers 2 data, then I will say that to go and merge temporaries bottom to pointer 1, and I will not forget to move pointer 1 ahead also. And in the else case, I will again say that temporaries next, not next, bottom. So this will be P2, and I will not forget to move P2, and yes, I will move my temporary also. And for the edge case, that if any P1 or P2 is left, if P1 is left, so I will say just go and merge them. Temporaries next will be my P1, and if P2 has leftovers, I will say that temporaries next is P2, and after merging them I will just say that return my next of dummy. So this merge function is another problem. Alright, you can go and check on YouTube or Google. I have also solved, you can check. So this way, if I submit this, so we can see we have a problem here. Okay, so I should use here bottom in place of next, and I should write here if root is null or root's next is null, so then I should return here root. Now if I submit this, so we can see that we have solved this problem now successfully. And if I tell the time and space complexity, we are just going to the end of the node from here to here. Let's say horizontally it has size n and vertically it has size m. So in the merge function we are just taking big of we can say 2m. So at max approximately I can say that time complexity is big of m cross n time complexity, and space complexity we can say that we are not using any space, so space complexity is big of 1. So this was all about this problem. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.